Alright, next question. You're basically unsure of the properties of the expanding universe and how gravity works, which isn't really your fault. I would think it's a common misconception. We tend to extrapolate the Newtonian mechanics of our everyday person and animal and automobile world to the large scale. Gravity wins is basically how it goes. Gravity wins at the very largest of scales. The scale here is important, so let's talk about it. Here's a picture of the solar system. The planets are clearly squished together more than they would be, but their relative sizes are correct. You can see on the left exactly how huge the sun is. It's ridiculous. And Earth is this tiny little blue dot right there. We're all on that little thing. Here's another example. There's the sun. Earth is a little dot you can barely see. And then the largest planet in the solar system, Jupiter, is still, I mean, really, really small when you compare it to the sun. And our sun is actually small for a star. It's what's called a yellow dwarf. And they don't use the word dwarf lightly. There are stars in the universe that are fantastically larger than the sun. Ridiculously larger. The universe is expanding. And not only that, but it's expanding at an increasing rate. Here, let's show you this one for... Here's a graphical representation of the expansion of the universe. You can see on the top right it says dark energy accelerated expansion. Despite what we would think, apparently the universe is expanding at an accelerating rate, so that it's faster. It's expanding at a faster rate now than it was just a minute ago. There is a form of energy that's fueling this that scientists now call dark energy. It's a code word. They use dark to describe anything that they don't understand. So this energy is coming from somewhere. We don't have any equations to actually accurately represent it, but it's making the universe expand faster over time. Really, really weird. We were talking about the solar system and how gravity works. Though the universe is expanding, the solar system stays together. The Earth isn't any farther away from the sun now, relatively, than it was a minute ago because of the expansion of the universe. The gravity of the sun keeps the solar system together and roughly the same size. Now, if you go up one more level from our solar system, you get to our galaxy, the Milky Way. We obviously exist within the plane of the galaxy, so a picture like this is just drawn. We don't have any satellite that we've sent out far enough to actually take a picture of the Milky Way galaxy on its end, but this is, as far as we can tell, this is pretty much what it looks like. It's the standard spiral galaxy. You can see Earth is located in the, I believe it's the Orion arm. It's kind of on the bottom, a little bit on the left, but basically straight down on the bottom. And gravity keeps the Milky Way galaxy together. The Milky Way galaxy isn't expanding either. And if we go up one step further, we can get to what's called the local group or local cluster of galaxies. You can see the Milky Way galaxy on the right, Andromeda, which is also a spiral galaxy and larger than our Milky Way galaxy, over there on the left, the Triangulum galaxy, Triangulum because, you know, Milky Way plus Andromeda plus the Triangulum makes a triangle. I know, that's bad. It's also a spiral galaxy, and it's actually orbiting the Andromeda galaxy, and we are all orbiting a common center of gravity, and the Andromeda galaxy is actually on a spiraling collision course with the Milky Way galaxy. So the Andromeda galaxy and the Milky Way galaxy will one day become one mush galaxy. It won't be a spiral anymore, it'll be more spherical. I think it's called like a globe or a globular galaxy or whatever. It doesn't matter. There's a bunch of other little things you can see, little dots all over the place. Those are other smaller galaxies that are all part of our local group. And gravity keeps all this stuff together. But past that, oh, here's another picture of the local group with all the different stuff that's actually part of it. Of course, in yellow you can see Milky Way, the Andromeda, and the Triangulum galaxy. Those are the three big players, and then everything else is real tiny, but still within the same gravity well. And we're all stuck together. Just for For reference, you might have seen this picture before. This is the Hubble Deep Field image. Basically, the Hubble telescope zoomed in on a very small and, to the naked eye, blank, as in just black without a star in it, spot in the sky, and zoomed in as far as it could and held on for a long exposure to see what it could see. This is what it saw in a very small and presumably very empty part of the night sky. Each of these dots is an entire galaxy. These dots are not stars. Each of these dots, all these funny little blobs, each one is a galaxy. So the universe is a huge, huge place. Here's this again. Yeah. So the universe is expanding, but gravity wins, and that stuff that is stuck together with gravity maintains its proximity to each other. Next, you brought up a couple of specific examples of anomalies within our solar system. Our solar system, is fairly uniform and regular, but there are a couple of oddballs out there. It doesn't mean that, well, for one, that a god must have picked up Venus and spun it the other way. Come on. You would think that he would have better things to do than to just mess up our solar system. Oh, turn Uranus on its side. Just because they're weird doesn't mean that there isn't a reasonable explanation for what's going on. Pluto's a weird thing, and it's actually no longer considered a planet. It's considered a dwarf planet and not a mere asteroid, because you can see from this picture Pluto is roughly spherical. It has enough gravity to squish itself into a ball, to crush itself into what gravity would determine would be the most efficient shape. If it had less mass, then it would stay lumpy like a potato, like all the other asteroids in the solar system. So here's some reference. There's Earth, of course, and then that orange thing in the upper left, that's Pluto. That's its size. So it's just barely big enough to actually get turned into a sphere by gravity. It's a Kuiper Belt object. It's only massive enough to be squished into a round thing, but it's basically just a rock floating out there in space. And it exists in a place with a bunch of other rocks, and you can see from the scars on its surface that it has suffered a decent number of collisions. Any decent-sized collision on Pluto would change its trajectory, change its orbit, change its rotation, change its orientation. Any collision would do that. Stuff is bumping into other stuff all the time in the solar system. This is an observable fact. It's nothing miraculous. You brought up Neptune next. Uranus. Uranus. That's funny. Uranus is roughly on its side. It's not perfectly 90 degrees off. There's a couple of theories about this, but the most accepted at this point is that it was struck very early in the formation of the solar system by a rock roughly the size of Earth on a certain angle. That would explain its weird orientation. And like I said before, collisions in the solar system are really common. So that is a reasonable explanation. However, it's up to editing. If somebody has some evidence or a new idea that mathematically works out neater and better, then that one gets adopted. No big deal. Nothing lost. Venus is a weird planet. Its orientation is roughly similar to Earth. The only thing weird about it is that it is spinning slowly in the wrong way. Now, why is this? There's actually a lot of debate about this. It doesn't necessarily make it miraculous or fundamentally unexplainable. And there's actually one theory out there that is a current favorite right now, but it's still up for debate. It's science. Everything gets debated. That's how you find out what's a good idea and what's a bad idea, because the stuff that actually survives a thorough criticism is apparently right. It's really complicated, and it has to do with the volume of gases in it, and it's getting gravitationally tidally locked to Earth when it's closest to it, and the Sun the rest of the time. and it ends up spinning it backward. It has to do with the mass of gases in its atmosphere. Really weird. There's this whole report that I was reading. I cannot make heads or tails of it. There's formulas all over the place, and I'm just not smart enough to understand. Ugh, look at all those equations. I'll see if I can screen capture it and put it in the video. I bet I can. Ugh, look at those equations. My brain!